So yeah, thanks for having me. This is a little bit of a different group to where I'm normally focused. My background, as we said, is fecal sludge. So generally I'm talking about moving vast volumes of poo from one place to another. But what's been really interesting is how well the scene's been set, the importance of appropriateness in low income settings. And that's one of the challenges we find with technology and where we are. And the cost benefit is something that I'm going to talk about as well. So why is water quality important to UNICEF? Well, access to safe drinking water is a human right. It's something that many of us take for granted. When you're thirsty, you'll just turn on a tap, drink some water, don't really think about it. But it's estimated that about 1.8 billion people still rely on drinking water sources that contain evidence of fecal contamination. And we use fecal contamination as an indicator because it's quite easy for us to grow, and it's quite a common cause of diarrhea. And diarrhea for children in developing countries and low income settings is a main cause of under 5 mortality, as well as stunting and poor development as children grow. 58% of diarrhea-related diseases are attributed to access to safe water, sanitation and hygiene. And it was really interesting to hear Louise's talk at the beginning about dengue and how that affects how dengue affects people's ability to get healthcare, and how dehydration is an impact on this. Drinking water and the Sustainable Development Goals. For us at UNICEF, we're trying to address the need for improved water through the Sustainable Development Goals, which many of you all know about. These, as part of this, if we're going to set a target, we need to monitor it. So this is where diagnostics become important for us. So in many lower middle income countries, there isn't water quality data available. And if there is, it's quite limited, and often focused on urban areas. When we start looking at rural areas or non-piped water supplies which serve smaller communities, there's even less water quality data because it becomes quite cost draining. So we use E.coli as the indicator in the monitoring for the SDGs. As I said before, it's relatively easy to grow, and it's quite simple in theory to test. As part of the SDGs, we are also looking at chemical contamination such as arsenic and fluoride, but I'm just going to focus on E.coli for now. And we have an indicator that is focused purely on this, which is where we talk about safely managed drinking water. And safely managed drinking water is where we should get 0 E.coli in 100 millilitres of a water sample. So all of this is part of a wider picture. As I say, I'm quite focused on water quality as an indicator and a measure, but these diagnostics form part of a systematic approach to safe drinking water, which in turn has an impact on people's health and quality of life. For us, we've got to see it as part of a framework, and how we get policies and subnational level legislation to have an infrastructure to provide water quality. But it also goes back to some of the things that people have already spoken about around how we engage communities, how we engage the user in water quality testing. So there's a community level of awareness. And I think it's interesting that a number of people have mentioned how the developments of technology, how the access to smartphones and internet networks has improved our ability to engage communities. But likewise, the technology alone is not the solution. I'm really pleased that other people have already mentioned this, because sometimes I feel it gets neglected, that you have what seems to be the perfect solution in your hand, but that doesn't mean it's going to be used. I'm a classic civil engineer. I like to walk into a community and I know what they need, but it doesn't mean it's what they want. And understanding those two different things are really, really important to a wider level solution. So how are we doing this in terms of our project, especially in remote resource poor settings, which is largely where we're looking at working? We've got limited access to labs, electricity, cold chains. We need solutions that enable us to understand the water quality and the implications for communities in these kind of environments. And ideally, we want this to be simple technologies that can be used by suitably trained persons. So just to explain a little about our use cases, in developing the products or reaching out to product developers, we've kind of divided our products into 3 use cases because we recognize no one product is going to fit all use cases, because we'll have different levels of education and different types of user. So we have the household surveys and the multi-cluster indicator surveys. These are what are used by UNICEF and WHO jointly to monitor progress against the Sustainable Development Goals. This is testing done across a sample in a country by trained survey teams. At the moment, we use pre-treated plates. I'll come on to what these are, that we can do relatively easily with a 100 milliliter sample, and then we can incubate using body temperature for 18 hours to get a culture-based result. These are cheap and easy to use. And actually, this is our largest volume of procurement because at the end of the day, any changes and product development we get need to have an incentive. So we do a bit of demand forecasting as to how much we see. And this comes back to what Connor was just saying about getting technology affordable in the use cases that we're using it. Our next use case is community-led monitoring and behaviour change. So this is having water communities that are often set up to manage rural water supply networks. They will report faults or issues, but we also try and get them to do some basic surveys and awareness raising around water quality. So this is a low educated user, but still actually one of our more important, because if the community can self-monitor their own system, then they can lobby their water supplier and have more control and more power to actually see a change made to their situation. And then the last use case, which is probably the most important but the least used, is the regulatory oversight and surveillance. Just because a country has water quality targets, how do they recognise that they're being met? And we've seen with COVID monitoring, for example, the importance of surveillance. It may not be something that we use to take a regulator to hold them to account, but it is really important in knowing what the situation is and how we're dealing. And with water, this can include fluctuation due to rainfall or seasonal change, dry season, wet season. This is when we see outbreaks of diseases such as cholera, because the change in the water supply is really important to the quality of it. So just to give you an overview of what a low resource setting looks like. These are some of the challenges we have for undertaking water quality testing when there is no lab available. So we work in remote locations. This is Indonesia. This is a foot-only access to some of the communities that we need to go to check their water quality. We're talking about non-piped water. This is Niger, and this is a rural borehole. And as you can see, that's the queue just to get the water out. And I can guarantee now that there's probably some kind of biological contaminant in those containers, let alone in the water source alone. And then the reality of actually getting to the field, this is wet season in Myanmar. As you can see, road access isn't great. And yeah, that is one of our vehicles blocking the road on the right-hand side. So in the reality of this, where we've got to carry all of our equipment and we've got to get to the field, and we need to do this regularly because monitoring needs to be done more than once a year, we have to be innovative. Our team in Myanmar managed to recruit this local elephant to get their vehicle out during rainy season when they were doing a water census. So, you know, we've got to think outside the box. So what do we currently do? So this is an example of some of the equipment that we already use. This is what I was talking about with the multi-cluster indicator survey teams. You can see all the equipment laid out there. And as you can see, the person doing the testing on the right is using a chair. Flat surfaces in the field are not always available. So doing testing of anything where you've got to lay equipment out and keep it sterilized is challenging. So the equipment may be foolproof, but there's the opportunity for user error is still pretty high. And that's on the belt. The green belt on there is what we use for incubation. You wear this belt under your clothes and you use your body temperature to incubate your culture. And it takes about 18 hours, which means you need to sleep in it. I've done this. I forgot that I had to go to a Pilates class and had to ask my husband to incubate my bacteria for me to ensure that my sample was still maintained. But it's not comfortable to sleep in, I can tell you that for sure. We also have some other testing equipment that we use for community monitoring. This is a H2S test, which doesn't even test E. coli. kind of tests for the hydrogen sulfide, I apologize, I hope I've got this right, that is produced by E. coli in the sample, and it's a color change reaction. So it's basically, is it present or is it not? And we get some level of quantification in the color change strength, but it doesn't really tell us that much information, plus it's not overly accurate. Or we could have a field kit. This is a lab field kit. So this is a 15 kg kit that is not particularly like to lug around. It includes an incubator, which means it has a battery. You can process, I think, 24 samples. But as you can see, again, team on the right are struggling to find a flat surface. And I know from personal experience that I quite often don't do this well enough to get accurate results. So part of the reason that water quality testing isn't largely carried out in the volumes it should be is because we don't have equipment that makes it easy. So what do we do at UNICEF about this? Well, we look at the ways to use innovation to solve identified challenges. And I'm so pleased that Connor said this at the end. It really made my day, that the design issue of what people think is needed in a low income setting versus what is needed is massive. It's really great to see some really cool innovation coming up. All this stuff around smart bandages is insane, but how does it translate to what we need in the field, and how does it translate to what's acceptable to users? So how do we do this? Well, first of all, let's be clear what I talk about when I say product innovation, because innovation is one of these words that people interpret in different ways. It could be something really high tech, or it could be something really simple. When we talk about innovation at UNICEF, we're looking at fit for purpose and value for money. These are the two key parts for us that allow us to kind of get the solutions we need to ensure progress for children and young people. And we very much talk about partnership. We talk about partnerships in terms of people in the field and programmatic experts understanding and defining the needs of children and our teams on the ground. We look at business and academia to develop the products to meet those needs. We don't do the product development. We need innovators like the people we're hearing from today to do the research to enable business to then pick it up and make a profit from it so that it can become cost effective and be used in low income settings. And then lastly, we look at programming partners and donors to get these products to scale, because it's all very well having a good solution if we can't reach economy of scale. It's about turning ideas into tangible and scalable solutions. So that's our approach at the Product Innovation Centre on innovation. How do we do this? Well, we as UNICEF work on defining the need. We scope out what the problem is and define it as clearly as we can. And then we open this up to research and development. We engage with developers, with academia, all sorts. We want to see them do the research and development because that's a more sustainable solution for the long term. And then we come back in at scaling it, getting the product into the right situation and refining it. So in identifying the need, we use something called a target product profile, and this lays out what we need a product to do, but not how, and the use cases with which we do it. And the target product profile for this particular project is 15 pages. It is the longest one we have, but that's because we've technically outlined how we need a product to perform. And the feedback we get from developers is that this makes their life easier because we know that if a product can achieve this, we will buy it. And the reason we work on this at Supply Division is because we're the largest humanitarian procurer in the world. We procure not only for humanitarian settings, but on behalf of governments. And that economy of scale appeals to developers, and it allows us to utilize our unique position. And then we work at scale. We do that. We do the procurement. We use public procurement processes. We tender for products and we use them for scale to get them where we need them. We also have a defined innovation process for this, which is on another slide. I'll show it in a second. And then we work with industry for co-creation to develop so that we don't expect someone to come to us with a final product. We will give the input and the refinement to get exactly that gap defined, as kind of highlighted, between what people think is needed and the reality of what we need in the field. And then we do use incentives on different projects as required. So these could be financial, it could be access to the field. It depends on what the appropriate incentive is for the project. I've spoken about the target product profile and how we do the need identification. The other thing I want to highlight is that we don't do research and development. It's not my job. My job is to work with developers, to guide them, to give thoughts and inputs, but it's not for me to do it. And to be honest, I don't have the technical background, and I'll explain to you in a second why, because this project has brought in some areas that we just didn't see was possible when it started a few years ago. This is our innovation process, and the reason we have this is so that we ensure we stay on track and we don't innovate for innovation's sake. It's really important that we have a very clear exploration as to why this project or gap is there for UNICEF, so that our time is invested appropriately and our resources invested as needed. This also allows us, we can move up and down this process as a project develops. And for this project, we're very much in the need and R&D phase, because the technology is only just catching up to what we're looking for. So what are we looking for? Great question. We're looking for something that's easy to use, cost efficient, and has a rapid detection method. Now, everybody has mentioned this already, especially the easy to use. But when I'm talking about cost efficient, for us, unless we can get these products to about $1 a test, we actually can't do this at scale. And that is a big number, or a little number, depending how you look at it. And we don't expect products to get there tomorrow. We do look at how we can support the development of these products to the economy of scale. And the rapid detection method, if we could have a test result within 2 hours, all of the access problems that I showed you would mean that we can use a result when we're in the field. Whereas currently, if it's 18 hours to get a result, and you spent 4 hours walking to the site, you've taken your water sample 4 hours back, that community will probably not be able to use that result. You're literally writing down a number on a spreadsheet. So we want to look at how we can use diagnostics and rapid detection to actually enable us to do more testing and better monitor to improve water quality. As I said, there's a target product profile for this project, and we did do a tender for this in March last year. What we found was that culture-based methods are only going to get so fast. We can only get to about 6 hours, which is not ideal, because that still doesn't give us a full working day in the field to work with the result. So how do we see this? So we've seen our use cases, the household surveys, the community-led monitoring, and the regulatory situations. And what we're trying to get to is something that's cost efficient, easy to use, quick time to result, and this will allow us to increase volumes and to reach the goals outlined in SDG 6. So where are we? Well, we did a request for proposals. We've got 11 responses, which showed us some improvement in time to result, but still not within the 6 hours that we're trying to get to, nowhere near the 2 we'd really like to get to. This shows us the limitations of culture-based products. We think these can help us with a middle kind of improvement, but it's not going to get us where we want to go. We'll field test what we got and see where we are. The challenge we have, and I really want to ask Louise about this from her keynote, is lab validation. How do we validate some of these products for field use? I'm really interested in the use of wearables, from the low-cost wearables, and how you can validate these to say that that result is accurate. If we're using these results to monitor SDGs, we need to know that the results are accurate in a field setting. And that includes the opportunity for human error, the competing biological markers. So E. coli is one bacteria, but there could be others, and how that affects the results of the products. We also understand these novel approaches. So novel are probably not novel, but we have 21 companies we've identified. There are probably more that are using technologies such as qPCR, tryptophan-like fluorescence, DNA and RNA mapping, and biosensors, so phages that act as proxies for E. coli. These technologies have the opportunity to get super quick. We all know that qPCR is like the quick test for COVID at the moment. Can we use that to identify E. coli? If so, can we be sure that we're identifying viable E. coli and not E. coli that's actually already died and there's no longer a risk to us? This is the challenge we have. So as UNICEF, we're engaging with different developers to understand the technologies and the approaches, but also at the same time, we're working with WHO as to how we validate these technologies for field use, because we have no reference standards for these use cases. And that, for many of you working in academia, you will understand the challenge. Writing any paper where you only have grey literature is nearly impossible. So we are looking at working with different regulatory bodies and different actors to validate. And then lastly is UNICEF. Our role is the market shaping. How do we influence? How do we get economy of scale and engage with country offices to get the growth that we're looking at? So what next? Well, we're looking at different partners for both scaling the products, for engaging with UNICEF. different utilities and regulators who might want to test these novel products, which are not standard technologies, and how they might use the results. We're looking at understanding these novel technologies and how we can use them in our use cases in low income settings, and how we influence the market. But the biggest challenge for us is definitely around this validation question. How do we know that a product is measuring what we need it to measure to a level that we need it to measure when we're lacking reference standards in a field setting? So that's what I spend a lot of my day thinking about. I've already run over, so apologies. Thank you very much. And yeah, I'll leave it there. Thanks.